Our next type of multiplication and division application is going to be area. So let's see how this applies to multiplication and division. Dan is carpeting a utility room in his house that is 4 feet by 3 feet. And we want to know how many square feet of carpet does he need? Okay. So if it's 4 feet by 3 feet, typically when we say this, we're referring to a rectangular room. Okay, so let's draw this side is 4 feet, and this side is 3 feet, and the opposite sides are the same length. Okay, so now let's break this into pieces. Okay, so let me do, here I have 4 feet, so just to make it easy, I'm going to break it in half, and then I'm going to break the halves in half, and pretend these are exactly equal in length. Okay, and then for 3 feet, I want to break this side into 3 equal pieces. Okay, now all of these squares officially should be the same size, but that's almost impossible to draw. I could have done better, but this will do. So notice what we're trying to find is the number of square feet in the carpet. Well, let's count them. So each square is 1 foot by 1 foot, and this is what we call a square foot. It looks like a little square. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And notice that's equal to 3 times 4. We could think of adding up the rows. Here there's 3 plus 3 plus 3 plus 3, which is 12. Okay, or we can add up the columns. There's 4 in each column, and we'd add 4 to itself 3 times, which is also 12. Okay. So here typically when we think about area, it doesn't really matter which side. Sometimes we call one the length and one the width, but it doesn't really matter in the context of the problem. Okay, so the number of square feet, we could write 3 feet times 4 feet equals, and we're going to write this as 12 square feet. Okay, and we'll talk in a lot more depth later about how these units work, but when you multiply a foot by a foot, okay, so notice this was a foot, 4 feet, this was feet. Our result is these little squares is what we're counting. Okay, so feet times feet equals square feet. Let's look at the next one. Dave is carpeting a utility room in his house that is 12 square feet. It says the length of the rectangular room is 4 feet. It says if the carpet fits perfectly, what is the width of the room? So that's our goal. Okay. So notice this is similar to the previous problem, but we know the total square feet and we know the length. We know one of these dimensions, we don't know the other, and that's what we're trying to find. So what would this picture look like? Well, I would start with the length of the room is 4 feet. So let's make this 4 feet, and I'm going to break it into 1, 2, 3, 4 equal pieces. Okay, and we're told it's a rectangle and that we have a total of 12 square feet. So I'm just going to fill in these one column at a time. So the first column gives us 4 square feet. Now I'll add a second column, making sure that it goes all the way down and that it's a rectangle. That's another 4 square feet, so now we have 8. And then I'll add another column, and that's another 4 square feet, which gives us our 12 square feet. Okay, so when we broke the 12 into 4 equal groups, each group this way has length 3, or 3 squares. Okay, so 12 square feet divided by 4 feet is equal to the length 3 feet, which is what we found. Okay, now if we wrote this as division, I'm going to write this a special way. 12 feet times feet, that's square feet. So notice up here we had the feet times feet gives us square feet. We want to divide that by 4 feet. And notice one of the foots cancels, and we're left with 12 divided by 4 is 3 feet. So again, you don't have to do this unit. We call this unit analysis. Unit are the units we're measuring in, but it can help you see the structure in the problem. Okay, let's look at the next type. Distance, rate, and time. So there's a relationship between distance, rate, and time, and it's that distance is equal to rate, which is like your speed, times time. Okay, so we'll look at these examples and this will become clear if we need, and sometimes we shorten this as d equals r times t. In the other direction, that's going to mean that our rate equals the distance divided by time, or time is going to equal distance divided by rate. Okay, so these are applications of multiplication and division, and the first one is the one we use most typically, but sometimes we know how far we've gone, how long it took us. We want to know how fast we're going. So let's look at the first example. Fanny is walking at a rate of 4 miles per hour for 3 hours. So that's our given information. How many miles did she walk? That's what we want to find. Okay. So notice we are given, this is our rate, 4 miles per hour. We're given the time, 3 hours. And we have this formula here. It says you multiply them. That gives you, we want our distance. Notice distance is measured in miles, so that helps you figure out which these are by the units. But let's look at a picture of this. We'll say that this is her start. She's gone, so we're trying to find how many miles. I'm just going to make this really long and call this miles. Okay. So 4 miles per hour for 3 hours. So in 1 hour, so I'm going to label this 2 ways. So in 1 hour, she's gone 4 miles. Okay. So here's 0 hours, 0 miles. 1 hour is 4 miles. After another hour, when she's been walking for 2 hours, she's gone another 4 miles, which is 8 miles. And after the third hour, she's gone another 4 miles, which is a total of 12 miles. Okay, so notice this is our result. We wanted how many miles did she walk, and we can get that by adding 4 to itself 3 times, okay, or 3 copies of 4, or multiplying the rate times the time. So we have 4 miles per hour times 3 hours equals, and we found that gave us 12 miles. Whoops. Okay. And let's notice how this applies with our units here. We have miles on top, hours. The hours cancel and give us miles. Let's look at the next one. Danny walked 12 miles at a rate of 4 miles per hour. How many hours was she walking? So this is our goal. Okay, and notice how this is similar to the last one, but it's kind of the reverse. Okay, and multiplication and division, they kind of undo each other. That's why these relationships hold. So let's see how we could figure this out. We have formulas, but let's make sense of it. Okay, we know that she walked 12 miles. So what I'm going to do here is I'm going to start with the miles, and I'm going to say this is 0 miles, this is 12 miles, and I know this is the total amount she walked. Okay, and it says she was walking 4 miles per hour. So now I'm going to start marking like we did up here. Okay, but in the last one we knew the hours and we filled in the corresponding miles to get our result. Okay, here we know the rate and we want to get to our goal of 12 miles. So we know after 4 miles per hour, we know it's 1 hour. She has gone 4 miles. Okay, I'm seeing that I'm not lining this up very well. We'll change this later. Okay, and then we know after 2 hours, she's gone 8 miles. Okay, and then after 3 hours, she's gone 12 miles. Okay, let me change this so they match up. Okay, and since we know she went a total of 12 miles, let's make this a different color because we were given that here. Here, our answer is 3 hours. Okay, notice in the last one, we were looking for the 12 miles. Okay, so we started with 0. Our goal was going to get to 12, and then we just added 4 miles, keeping track of the hours to see how many hours it took her to walk. Okay, so let's see what this looks like. We have 12 miles. We divided that by 4 miles per hour, and this gave us a result of 3 hours. Okay, we could write this as a fraction within a fraction, okay, but just notice for now that when we're dividing, the units cancel out on top instead of top to bottom like they do with multiplication. Okay, we have one more type. These are called multiplicative comparisons. Chuck has 3 times as much money as Tony. If Tony has $4, we want to know how much does Chuck have. So we know that, let's start with this, Tony has $4. Let's just make a little box and put $4 in it. And this is Tony. And then we know Chuck has 3 times as much money as Tony. So for Chuck, we can make 3 copies of what Tony has. So 3 copies of $4. And notice that means that Chuck has $12. We could add these all together, or equivalently, it's 3 copies, 3 times as much of $4 is 3 times $4, which is $12. Okay. Notice here that 3 doesn't have a unit. Okay, we're multiplying dollars times a number, and we make those copies, and our result is also dollars. Okay. And here's our division problem. That's going to be the reverse situation. Chip has 3 times as much money as Timmy. If Chip has $12, how much does Timmy have? Well, let's draw Chip's dollars. So Chip has $12. Okay. Now that's 3 times as much money as Timmy. So we want to break this, okay, or we'll say cut into 3 equal pieces. And we could count this out, but I'm just going to turn it into 3 pieces. And if the 3 pieces are equal, they would each be $4. So again, the reverse of the last situation. So that means if we take $12 and we divide it by 3, the result is $4. So Timmy has we would actually say 1/3. That's a fraction, but we'll talk about that later. Okay. And this is Timmy's amount relative to Chip's. Okay, so be careful with these with looking at the times as much because you just want to multiply the numbers. But in actuality, this is a division problem.